question number 10, we have what mass of SO2, sulfur dioxide, this is sulfur dioxide, is produced from the reaction between 31.5 grams of sulfur, elemental sulfur, and 8.65 grams of oxygen. We go through the normal procedure for finding out the number of moles of sulfur. We don't forget to multiply the molar mass by 8 because naturally occurring sulfur is S8. So we get that many moles of S8. Oxygen is diatomic, so we multiply by 2. 8 divided by the molar mass. So oxygen gives you that many moles of oxygen. And I picked sulfur as the starting point of my calculation. And I included the stoichiometry, which is 8 to 1. So 8 moles of oxygen are used for every 1 mole of sulfur, resulting in 0.98 moles of oxygen are required. But only 0.27 are available. So that tells us that oxygen is the limiting reagent. So because oxygen is the limiting reagent, that's where we begin our calculation to find out how much sulfur dioxide is produced. So we start off with the amount of oxygen that we actually have, and we include the stoichiometry for the reaction. 8 moles of oxygen are used for every 8 moles of sulfur dioxide that appears. 8 over 8 cancels to 1. And notice how I put moles of oxygen in the bottom because I want to cancel moles of oxygen so that our answer is going to be in moles of SO2. We get 0.2703 moles of SO2, giving us, when you multiply by the molar mass of SO2, 17.317 grams of SO2. We're only allowed 3 significant figures because the 2 numbers that we initially started the problem with had only 3 significant figures. So our final answer is reported as 17.3 grams of sulfur dioxide. Continuing here, number 11, the question asks, what mass of SO3 is produced from the reaction of 12.4 grams of sulfur dioxide and 3.45 grams of oxygen? Again, a similar problem. In this one, I took the liberty of balancing this equation by using the number 1/2 for oxygen, because you only need 1 oxygen atom added to SO2 to give you SO3. But some students pointed out they don't like fractions, so what I did is I doubled everything, and that's perfectly fine. You get 2 sulfur dioxides plus 1 O2 gives you 2 sulfur trioxide. I went again through the normal procedure of finding the number of moles of sulfur dioxide. Here it is. The number of moles of oxygen. Here that is. And then I started my calculation from oxygen this time because I suspected oxygen was the limiting reagent. I found out, using the stoichiometry, 2 moles of sulfur dioxide per 1 mole of oxygen used, that 0.2156 moles of sulfur dioxide is required. But I actually have 0.19. So that means the sulfur dioxide is actually limiting. So even though I thought O2 was the limiting reagent, and I started the calculation with O2, I found out the other one was limiting, and that's fine. So I started my calculation with 0.19 moles of SO2, which is what I actually have. I included the stoichiometry for the reaction, which is 2 to 2, which cancels to 1. Again, how did I choose which one to put on the bottom, which one to put on the top? I want to cancel SO2. So I put SO2 on the bottom for the conversion factor, and that gives me an answer in moles of SO3. So that's how many moles of SO3 is produced, and then I simply multiply by the molar mass of SO3 to find that it produces 15.496 grams of SO3. Again, there are only 3 significant figures. The problem was started, the question was posed with only 3 significant figures in the numbers that were given, so the answer can only contain 3 significant figures, and it comes out to 15.5 grams of SO3 is produced.